Hello Algebra 2 students, this is lesson 28. Our objective for today is how do you simplify complex fractions. That's what we're going to be talking about first right here. And then how do we simplify, or how do we rationalize denominators. And we're going to talk about that in the third slide here. So first of all, we know how to do this. Right? We learned this back in 6th or 7th grade. 1/3 divided by 5/8. You would just simply go 1/3. That's not exactly what I wanted here. You would say 1/3 multiplied by 8/5. Remember, just change that to a multiplication sign and multiply by a reciprocal. Then of course you'd simplify and work that out. But this seems pretty normal. But what about this crazy looking thing? This is what we call a complex fraction. It's a fraction with fractions in the numerator and denominator. So it's like a fraction with fractions in it. So we call it a complex fraction. But really, that means the exact same thing as what I just boxed in up here in green. So it's actually going to be the same idea, and just kind of the trick to solve these is you simply multiply the numerator and the denominator, the top and the bottom, by the reciprocal, or you flip that over, by the reciprocal of the denominator. And just real quick, let's see what that does. The reciprocal of the denominator is 8/5. And over here, multiply this by 8/5. Well, remember we multiply the top and the bottom. So the top's going to be 1/3 multiplied by 8/5. And the denominator is going to be, well, the 5's reduced and the 8's reduced, so it's going to be over 1. Well, anything over 1 is just that thing, so 1/3 times 8/5. Well, doesn't that look really familiar as this? So, we do the same idea to solve these. Let's see if we can get into some and solve them. So it says, practice A, our instructions are just to simply simplify. Simply to simplify. So we're going to use that trick and we're going to multiply both the numerator and the denominator by the reciprocal of the denominator. So P over Z plus X. So this is the reciprocal of this. And so I'm going to multiply both the top and the bottom by that. P over Z plus X. And remember, this whole thing right here is just simply 1, because it's some number over some number, right? This number and this number are the same. So any number divided by itself is just 1. So I'm not changing the value of anything. I'm just trying to simplify this whole thing down. So notice on the numerator, this P will reduce with that P. And so I will end up with M over Z plus X divided by, well, this Z plus X reduced with that Z plus X. This P will reduce with that P. So this all just becomes 1. Or really we just say M over Z plus X. So this big scary thing right here turns into this semi-scary thing right here. Now, you don't necessarily have to write this step. I did just so you can remember what is going on. But if you do that a few times, you'll start to realize, hey, I see a pattern here. I can just do the numerator because the denominator goes to 1. So let's try another one here. So I'm going to multiply this one by the reciprocal of the denominator. So X plus Y over Z. X plus Y over Z. Again, this thing here on the right is just simply 1. So I'm not changing the value of anything. This X plus Y will reduce with that X plus Y. This Z will reduce with that Z. And this X plus Y will reduce with that X plus Y. So everything on the denominator becomes 1. And on the top I end up with just that Z and the M. M over Z over 1 is just M over Z. Okay? Alright, now this, I took a picture of this from your book. It says an expression that contains square root radicals is in simplified form when no radical has a perfect square factor and no radicals are in the denominator. Well, doesn't that seem confusing? So let's just break that down just a minute, because pretty much what we're doing, pretty much what this is saying, the green part all in here says if you're asked to simplify something with a square root, do these two things, the red and the blue. So notice down here it just says simplify, and these have radicals in them. So whenever it says simplify and we're dealing with radicals, we're trying to do these two things to make sure it's in simplified form. First of all, this red, simplify down the radical. So that means if you had something like the square root of 75, remember that's the square root of 25 times 3. That's the square root of 25 times the square root of 3, so that'd be 5 square roots of 3. You should know how to do that before, but that's what this is saying here in the red. Is to simplify that. And then in the blue, it says no radicals are in the denominator. Well, that literally means no radical parties in the basement. Okay, I stole that from a coworker of mine, but I think it's awesome. No radical parties in the basement means that you should never have radicals in the denominator down here in the bottom. So if you see a radical in the bottom, that means you're not simplified. You still need to get that out. I'm not exactly sure why that rule is, and if you get up into Calc 3 and onward, sometimes we don't even take them out. But it's a skill we're wanting to learn right now as far as taking out. So for right now, simplified means there's no radicals in the denominator. Okay? Now, in order to get them out of the denominator, we need to go up here, which I don't know why I wrote it up here, but anyways, we need to remember this stuff. Remember, if we have x times x, it just gives us x squared. So 2 times 2 is 2 squared, or 4. So if we have something like this, the square root of 5 times the square root of 5, that's the square root of 5 squared, or you could say the square root of 5 squared. These two mean the same thing. Well, remember, square root and squaring are opposite operations, or if you really wanted to think about it, this is the square root of 25, right? 5 squared is 25, which just comes out to be 5. So we're going to use that fact that if we multiply a radical by itself, it kind of gets rid of that radical sign. Okay? So that's what we're going to do here, is when it says simplify, we're wanting to get rid of the square root of 2 in the denominator, because we can't have radical parties in the basement. So we are going to multiply this by 1, and the one I'm going to choose is multiplying by the square root of 2 over the square root of 2. Now I picked the square root of 2 because this has a square root of 2 in it. Okay? Now whenever I multiply these, the top comes out to be 4 times the square root of 2. My denominator comes out to be 3 times the square root of 2 times the square root of 2. But of course, this part right here is really the square root of 2 squared, which is simply 2. So this is going to come out to be 4 square roots of 2 over 3 times 2. Or 4 square roots of 2 over 6, and I'm coming down here. And of course we can reduce this 4 and the 6. 2 goes into 4 2 times, 2 goes into 6 3 times. So I'm going to have 2 square roots of 3 over 3. And I don't know why I changed that to a 3 in there. I apologize. 2 square roots of 2 over 3. Alright, let's try one more of these. So this one I'm going to want to multiply by, that's right, the square root of 5 over the square root of 5. Again, remember, this is just 1, so we're not changing values. Same with this thing, it was a 1. So this is going to come out to be 3 square roots of 5 on the top. In the denominator, I'm going to have 2 square roots of 5 squared, which comes out to be 2 square roots of 5 over 2 times 5. And I'm noticing right here, why do I keep changing numbers? It must be late or something. That's a 3. And then this is going to be 3 square roots of 5 over 10. The 3 and the 10 don't reduce, and I can't reduce the 10 with the 5 because the 5 is under the radical. So that's going to be my answer. 3 squared root of 5 over 10. If you haven't noticed already, your homework is on page 129. You're doing 7 through 21 all, and then 5 more of your choice. Good luck.